Alternating series tests. So, when it comes to alternating series tests, a alternating series is a series where generally it's going to alternate between a positive and negative values. Now, a lot of times what these series are going to look like is -1 to the n over, let's say, n to the 5 over 3. Or actually, let's say n to the... Let's say n to the 5 over 2, 5 halves. Now, in a situation like this, what you notice is this -1, for each n, this -1, if it's an even number, then this will be a positive 1. If it's an odd number, this will be a -1. Now, the idea is we see if this series converges, the absolute value of a to the n converges, right? So the absolute value of a to the n would be infinity 1 over n to the 5th, 5 over 2. Since we're going to since this takes care of the fact that sometimes this will be negative, we're going to treat it as if it was always positive. Now, this 5 over 2, this is a p series. So, since this converges, right, due to p series, converges, then we know that this converges, and it converges absolutely. Now, in the case that it doesn't converge, it can converge conditionally. For example, the series -1 to the n over root n. Now, for this series, when we evaluate it, it's going to a to the n is going to equal to the of 1 over n to the 1/2, right? Now, because of p series, this is going to diverge, right? This is less than 2, the series diverges. So, from here, we check and we see simply just the limit as n approaches infinity of 1 over n to the 1/2. Now this, if this approaches 0, then the series converges conditionally. Now, since this is increasing, this remains constant, this will equal 0. So this series converges conditionally. Now, if none of these requirements are satisfied, it diverges. For the limit -1 to the n over 2n plus 1 over 5n plus 1. Now, of course, find the absolute value, we get 2n plus 1 over 5n plus 1. And from here, we can see that because of the divergence test, the limit of this is going to approach 2/5. So it diverges. And now we only know it diverges conditionally, or it doesn't. We only know that it doesn't converge absolutely, right? So this diverges by the divergence test, so it doesn't converge absolutely. But the test for absolute divergence is simply the divergence test. So technically, we would do this again. 2n plus 1 over 5n plus 1 equals 2/5. Since it doesn't equal 0, this diverges absolutely.